Hello everyone. Just recently I made a video and posted it up on YouTube in regards to making a flame out warning using telemetry on the core, and that was fairly well received. However, I did have a question from a viewer in regards to basically disabling the standard throttle trim and using a switch, a 3-position switch or a 2-position switch to simulate the throttle trim. He wanted to know basically how we can do this on the core and atom radios. So in this video I'm going to show you how to do it. It's actually fairly simple, but one or two little tricks involved. Okay, so just to refresh everyone's memory, if we look at the actual trim, so this is my model that I was using for the previous video on doing the telemetry for the flame out, or the flame out function. So I just had one single throttle function set up, single servo, which went to the ECU of course, and you notice here I've got trim C, which is this trim here. So my throttle sticks on the left hand side because I fly mode 2, but I use opposite trims for my aileron, elevator, rudder and throttle. It's just, I find it easier to trim out a model with opposite trims. And so my throttle trim's on this side here, trim C. If we go into the actual trim function, if you look carefully at this curve, you'll notice that there's a light grey shaded area, and if I move the actual trim lever, you'll notice the little line. If you look carefully, you might have to magnify the video. You can see the 3 positions that I've programmed into this particular trim lever. So I've got a low trim, mid trim, high trim, which is pretty much standard for a jet cat sort of starting sequence, especially with the older turbines. I know some guys, like with Exakoi and that, you can use just a standard 2-position setup. And this video will, basically, I'll use the 3-position example, but you can use the same programming technique to activate it on a 2-position switch. So at the moment, what I've got, if I go to my servo travel screen, now you can have a look at my throttle servo percentages there. With low stick, at low trim, I've got negative 110% travel. Then at mid trim, I've got 100% or negative 100% travel. Then at full high trim, I've got neg 90, so negative 90%. So we're going to emulate that with, say, this switch here, with this 3-position switch. So how do we do it? Okay, first of all, let's have a look. Let's go to the function menu. So back to our function menu. So the function menu is probably the most powerful feature within the core. You can have some quite complex programming going on here. Doesn't look very complex at the moment, but as most PowerBox and core users, PowerBox Atom and core users would be aware, the basically the heart and soul of the programming is all done within the function menu. Okay, at the moment we've got the throttle. Let's delete the trim out of here, because we're not going to use the trim lever. So trim's deleted. So I've just got a couple of dashed lines in there indicating there's no trim. Standard throttle setup controlled by my stick A, which is the throttle stick for a mode 2 pilot. And then we've got it assigned to channel 1. And channel 1's our throttle servo. So that's just the servo output on that screen for that function. And just one thing to be aware of for those that are not familiar with PowerBox, core and atom radios. You've got your center, which is basically your center. This figure here called way, that's basically your endpoint adjustment, or sorry, your travel adjustment. And then you've got your maximum endpoints, which is called the limit in this particular radio system. So our limit's our maximum travel, way's our standard endpoint adjustment, or travel adjustment I should say, and center's your center. So you can see I've got it set to a negative 110% maximum and plus 100% maximum. So full throttle is 100% for the ECU, and low throttle's at the moment it's negative 100, but with the trim, if the trim was enabled, it would allow us to go to neg 110 for this particular example. It's just the way I had set it up for the example. Okay, so that's just our throttle stick. Now, just clicked on one too many arrows. Let's introduce a new function. So this is where we're going to define our throttle trim. So let's make a function called throttle trim. This is what I love about the core insofar as the function menu is concerned. This allows a lot of flexibility. It's the heart and soul of the radio. Okay, throttle trim. No big deal. What are we going to use to control the throttle trim function? Well, we're going to use this switch. So let's tell it we're going to use a switch. Switch J. Okay, so far so good. And we also want it to work on servo 1 as well, which is our throttle output. So let's select throttle. And it gives us another servo menu. So this servo menu here is specific just for the throttle trim function. So not to be confused with the actual throttle function. Now, you'll notice the default travel adjustment is -50 and +50, and that's the default on the core and atom radios. And the reason PowerBox do this is if you're setting up a new model and you might have some linkages attached to your servos, it defaults to sort of half travel so you don't accidentally overdrive the linkages. Let's go back to the main function screen. I just want to highlight this again. So if we look at the throttle function, not the trim function, but the throttle function, so that's our normal throttle. Go into the servo menu. So this is specific just for the throttle function. So our throttle stick, and you'll notice we've got a travel adjustment of plus and minus 100, center 0, and we've got an endpoint limit, maximum endpoint limits of plus 100 and negative 110. Basically, the trim will be able to shift the servo down to the negative 110% mark. So, remember, throttle servo. Let's now go into the throttle trim. Same throttle servo, but now we can define our own unique limits just for this function. Okay, so for our trim, in the previous example in the video that I shot for the flame out warning, I'd set my trim to have an adjustment range of plus and minus 10%. So we're going to do the same thing here. So at the moment, you'll notice if I flick the switch, I'll overdrive the servo in this direction, and it hits the hard limit of negative 110%, of course, because it's trying to drive it to neg 50, or basically neg 50 from that point, and it can't because it's stuck on negative 110%. That's center, and that's with the switch thrown the other way. So let's make a limit of, say, plus or minus 10%. So all we need to do is reduce these figures here to say plus or minus 10. So we've got positive 10, negative 10 and 0 in the middle. So at the moment I'm on 0. And if I flick the switch away from myself, I have plus 10. And if I go all the way towards me, I have negative 10. And you notice the negative 10 actually now drives the servo to negative 110% correctly. We're not overdriving that. It's all very well. Just one thing to be aware of is which way we're going to have this switch operating. So my personal preference is to pull the switch towards me to enable the turbine. And to enable the turbine, I have to increase the trim. So I need a higher positive value or more positive value. And at the moment it's going the wrong way. So basically when I push it away from myself, I'm getting a higher output rather than less. So more negative this way, but I want it to work in the opposite direction. So basically when I throw the switch towards me, I want a more positive value and a more negative value going the other way. So we need just to reverse the servo function just for this function. And all you need to do is, you'll notice here we've got a direction column, and all we need to do is long press on this little icon, and you'll notice it changed from normal to reverse. I'll just do that again. So it's a long press. So that's normal. And if we want to reverse it, it's now reversed. So now when I pull it towards me, this bar graph should move to the right a little bit. And there we go. So I've got the direction now working as I want it to work. And as a matter of fact, at low throttle now, it behaves just like your normal trim. So you notice here in mid-stick, you've basically got negative 100. If I pull it towards me, it should go to -90, which it does. And if I go fully the other way, it should go to -110. So that gives us a plus or minus 10% either side of center operational range. Now remember, you can use a two-position switch. And if you want to use a two-position switch, you can set it up the same way and just basically check your direction, that's all. Easy as. So hopefully you follow it so far. Now, the only drawback with this is that it impacts the this trim function will operate across the whole servo range. So for instance, if we move the throttle stick high, say at 3/4 throttle, roughly 3/4 throttle, if I move the switch, you'll notice the throttle's changing, because that's the actual output of the throttle at the moment. And we don't want it to change at high stick or above half throttle. So we only really want it to impact the low end, which is where we want our trim to work, just like a normal trim operates. So how do we do this offset? How do we get this offset in so it only operates at the bottom end of the range? Well, pretty easy. Let's OK this. Let's go back a step. Now, you notice there's a curve function within the function menu here, or for each function I should say. So let's have a look at that. We'll go into there, and this gives us a curve for the actual function. So remember, this is a throttle trim function. So this is not just for the servo, this is for the function. Now we're going to pull one or two little tricks here. At the moment you'll notice there's a linear curve from left to right, and basically with our switch in any position, it just means that as we move the servo, it'll give us our normal default throws, no matter where the throttle stick is. However, how do we change this response? Well, one way to do is using flight modes, but we're not interested in that. Let's have a look at this control rate feature. So, control rate, what that does is normally that defaults to 100%, because basically you want whatever function that you're incorporating to have your normal 100% throw at any position along the curve. But we're going to modify this, and if we click on here, we're going to set the throttle stick to control that curve. And you'll see how it'll all play out in a minute. So you notice the control rate, we've assigned stick A, which is our throttle stick. And if I move the throttle stick, if you look carefully, we have three rates to choose from. You have like a rate at position 1, and as I move the stick, it'll change over to position 2, and I keep moving it changes to position 3. So we're going to do something here that's a bit odd. We're going to modify this rate in 2 of the positions. So at the moment, we've got 3 positions, and you can select an individual rate for all those 3 positions. Now don't forget, we're controlling it with a linear encoder, so basically a linear input. Let's move the stick to mid stick. So we want to get this exactly center, so I'll just go to throttle. I'm going to put this switch in center as well. So I'll make sure that's on 0. There we go. If I go back to the screen here. Now, here's the trick. So remember, we're at center stick. So what that's basically saying, at the moment, this switch has 100% range with the throttle stick at center. So in other words, if I throw this switch, it has its normal 100% range. But we don't want it to have 100% range with the stick at center. We want it to have virtually 0. So let's reduce the rate and make it 0. Let's make it 0. Okay, that's okay for mid stick. Let's go to full stick now. I'll just hit the endpoint there. At full stick, we basically want to disable this switch, or this function, which is the throttle trim function. So again, what we're going to do, oops, I disabled it. We're going to reduce it to 0. And we don't need any exponential. Not that it's set anyway, because the values are at 0%. So basically at full throttle stick, this function, remember this switch is controlling the throttle trim function, has 0 impact, has 0 rate, so it can't do anything. And it's the same all the way to half stick. So at half stick, if I go to half stick, again, 0%. Now, if we go below half stick, as we move below half stick, you'll notice the rate starts to increase. So just below half throttle, we have, say, 10%. So what that, well, around about 10%. There you go, 10%. So just below half stick, got 10%. So what that means is this function only has 10% impact over its whole range. So for instance, remember how we've set this up to plus 10% and minus 10% travel? At the moment, if I flick the switch, it's only going to give me 10% of that 10% travel. So it's only going to give me 1% throw in either direction. However, as I bring the throttle stick down to low, you'll notice this rate keeps increasing. So now throttle trim's getting, throttle trim function has more rate command. And by the time we get down to low, this switch now has its full throw. So the full throw, remember we programmed it for plus or minus 10%. So hopefully that's clear. So at low stick, we have full plus or minus 10% function of the throttle trim. However, as we bring it up to mid stick, that throttle trim starts to reduce at this value here. And by the time we get to mid stick, it's 0. And at 0, basically this switch basically has no impact on the throttle trim. Hopefully that's clear as mud. So let's go to the servo output screen. So let's go to full turbine off condition. Notice minus 110%. And if I flick the switch, it'll then go to 100 and neg 90. So negative 90, that's my normal start position for my JetCat turbine, for instance. So now we have a 3-position switch mimicking exactly what the original trim lever did. Simple as that. And just as we were talking about a few minutes ago, if I move the stick to, say, over here somewhere, which is just above half stick, it has no impact. It has 0 impact. If I move it to, say, just below half stick, it has some impact, but you notice it's not the full 10%. So you got what, 49 to 44, so there's only 5%. At bottom throttle stick or low throttle stick, you have the full 10% throw. Okay, hopefully you enjoyed that, and hopefully that's useful to some that want to use a switch for your throttle trim for your turbine. Thanks very much. Thanks for watching.